So in this video we'll be discussing about scaling the data. Scaling a data is a pre-processing techniques used to standardize the range of independent variables over the features of the data. So what it ensures that a model con- uh, equally contribute to the performance of the model. So we'll do min max scaling. Here the transformation lies between 0 and 1. So x dash equal to x minus mean. So whenever we'll have the features, we'll minus the mean, and then we'll take the max value and the minus the mean and divide that. So it's a not a when the distribution is not a Gaussian distribution, that time we'll use min max scaling. When you need to maintain the original distribution of the value, so that time we'll use min max scaling. So you can see Python program. So we'll go to Visual Studio. So we have sklearn library. So from sklearn library we'll import pre-processing, and inside that we have min-max scalar. So min-max scalar is a function. We'll import that. We'll take that function and we'll store it in the value called scalar, and in the scalar we have fit transform. So what we need to fit inside that fit transform numeric df compensation. So when we pass the numeric df compensation and scale the data, we'll see all this data as a scaled data. So another min max scaling we have seen. Then we'll go to another scaling type, that is standard scaling. That is nothing but z-score minimization normalization. So z-score normalization, here mean equal to 0 and standard deviation equal to 1. So the formula is x dash equal to x minus mu, that is mu is a mean and rho is a standard deviation. So we will minus the mean and divide by standard deviation. But it used when the data follow Gaussian distribution. So first one is used when it's not follow the Gaussian distribution. That time min max scaling is used, and when it's followed the Gaussian distribution, then z score normalization is used. So we'll go and see how z-score normalization is used. So inside that we have again in sklearn library, and inside the pre-processing we have a standard scalar. So we'll store it in the variable called scalar and fit transform numeric df compensation, and we'll see scale data. So that this is the scale data. And another is if we want to do formula wise, so we'll take the ilog numeric df compensation. It start from second till the 11th row of the data, 11th column, and then we'll select that and we'll apply the lambda functions. And what we'll do, we'll minus the mean and divide by standard deviation, and we'll take the head command and we'll see that there are five rows in the data. So it is displayed like this. So this is called z normalization. Now we'll go to our notebook and see we have another type, that is max absolute scaling. So max absolute scaling, when we'll do that, we'll scale the data by its minimum absolute value representing sparsity. So the data will be sparse. One will be here, one will be here. It will be sparse everywhere. So we'll take the data, we'll divide by maximum value of it, and it is used for so now when you use it max absolute scaling, when the data is sparsely distributed. Sparse feature, data with sparse feature is that time we'll use that. So max absolute scaling. So again, inside the scalar pre-processing we have max absolute scalar, and inside the scalar we have max absolute scalar, and then inside the scalar we have fit transform. So we'll pass the numeric DF compensation scale data, and we'll see that max absolute scaling have been used here for sparse feature. So now the last one is robust scaling. So when you use the robust scaling, scales the data when the medium and the interquartile range, making it robust to the outlier. So when medium and interquartile range are robust, means it's cannot be changed to the outlier. So that time rigidity is there, that time we'll use the robust scaling. So that time we'll minus the q1 and divide by q3 minus q1. So where q1 is and q3 are the first and third quantile. So again we'll go to the code, and we'll see from sklearn pre-processing import robust scalar, and we'll take the robust scalar function and we'll store it inside the scalar, and scalar dot fit transform numeric DF compensation, and we'll see that a robust scalar have been used here. So now we'll go now the question is when you will say that when to scale the data. So scaling is essential for the algorithm that rely on distance metrics. So whenever something is rely on the distance metrics, that time we'll use the we have to scale the data, there is no other options. So guys, that's it for the videos, and if you like the videos, please do comment, like and subscribe, so that I'll get motivation towards making another video. Thank you.